hey, that must be side-side angle. All right? Now, normally I might check to make sure it's side-side angle, but if I say determine the number of angles, you can pretty much assume it's side-side angle. And as you draw it, you'd realize it is side-side angle. So in order to draw a side-side angle, the first thing you're going to do is draw your angle. So we're going to go ahead and draw our angle. And that angle is 41.2 degrees. And that was our alpha, so that means that's our angle A. Well, if we look across from angle A, that's going to be our dangling one, right? It's the one that can kind of spin. It'll dictate how many solutions we have. Well, that length was 8.1. And since I stated this comes off right here, do you see how I stated how long this line was? You have to put the 10.6 here. That's why the 10.6 goes here. Because we define this point. We define this point, which tells me I know this length, which means I must have been given this length. Don't put the 10.6 on here because we don't know that length. That is going to be dictated by how long this line is and whether it's going to hit the line or not. Because if this hits once, this line is actually going to be shorter. So this is how these are always going to look if I ask you to determine the number of triangles. You should have an angle, a side, and a side, and that side should dangling. The more times you repeat just this procedure, rather than doing it in multiple different ways, just keep repeating this method and you'll get it right. Okay, so your first question is this a type 4? And a type 4 is if it's one oblique triangle. Does anyone know if it's one oblique triangle or how to do that check? Yeah, John. Right. So if this line here is longer than that line, then it's one oblique. Is this section longer than 10.6? No. No. 8.1 is definitely shorter than 10.6, so it is not case number 4. Always do that check, because guess what? If that was the case, if this would be 11, you'd be done, and the people that missed it would be doing all this work with finding the length of the height and stuff, and then they might end up getting the wrong answer. So always do that check first. Is my dangling arm longer than my fixed arm? No, it is not, so that means I need to find the height. And our height is going to create a right angle. So we do have a right triangle here. So we can use sine to get our opposite over hypotenuse. So we have sine of 41.2 equals opposite over hypotenuse. So that's going to be sine of 41.2 degrees is going to equal opposite, which is h, over our hypotenuse, which is 10.6. Multiply both sides by 10.6, and you're going to see h is going to equal 10.6 times sine of 41.2 degrees. And that gives me that h is about, I think it was 7? Yeah, about 7. So that means my dangling arm one, the one that can rotate, is longer than my height. How many triangles do I have? 2. So since our A is less than our H, we have 2 triangles. Oh, greater than H, sorry. No, I was thinking of what I was going to say next. We did already do that check that A was less than B, right? So that's why this is true. Okay, so A is bigger than H, and we already did this check that A was less than B. So that makes it 2 triangles. That's why I always do that A and B check first. That should be the first thing you do. Is my dangling arm longer than the other arm? Yes or no? We'll tell you what to do next. All right, any questions on this? All right, this was the most important part I wanted you to take out of the homework, is that you can tell how many triangles there were. Okay? Saying that, what questions do we have on the actual homework? Yes?
27.
27. So 27 kind of had a trick to it. '27 kind of had two tricks to it. So 27, we have a quadrilateral. And it says, I want to find the area of it. We didn't work with area of quadrilaterals. So what we need to do is we need to draw this as something that we've already done, and that's going to be two triangles. Because if I find this area and this area, add them together, I have the whole area. Well, that bottom triangle, well, that isn't a hard one to find the area of. I'm not actually going to find the area. I'm just going to walk you through how to find it. So remember, the area of a triangle is half your base times your height. We already have a base. We just need to find the height. Well, the height, once again, makes a right triangle. So we'll just call this H1. We'll call it H1. If I'm looking for H1, I'm just going to say, well, the sine of 45 degrees equals that H1 over our hypotenuse of 2 square root of 6. All right. Are we okay using that to find our H1? And it's just half of H1 times our base. That is that area. It's almost the same problem as this one. The tough part about this one is I can't drop a hypotenuse here. I can't drop a height here. If I would drop a height right here, I don't know this angle measure, right? So this one we had to think back to a geometry class and say, well, if I extended this guy, let's extend it in green. If I extended this guy out, and I draw a line up here, I can call that my H2. That's the height of the other triangle. Well, that's going to tell me that this little sliver right here is going to be 30 degrees. Well, I don't really care about that one. This guy right here is going to be 60 degrees. That's my 90 degrees. So this is the exact same thing. I am just going to use sine of 60 for my H2, sine of 60 degrees is going to equal my opposite, which is my H2, over my hypotenuse, which happens to be 4 on this one. And that's going to get your height 2, where your base is 10. So it'd be half of 10 times whatever you get for H2, plus half this base times your height, whatever you get for H1. Does that?
Yeah.
Yeah. It's a tougher of a problem. Okay. Other questions? Yeah.
I have just kind of an overall question.
Yeah.
On the answer key, when it was rounding, it rounded before I did. I just put in the complex number, so I got different numbers, but they were really close. Is that right?
Absolutely. I give you full, I mean, if I come up with 62.3 and you come up with 61.9, we're probably, you just rounded different than I did. If you had 30, then we had a problem. But as long as you're in the same ballpark, like you said, I'm not going to take any points off for that. In fact, I'm going to error on the side that you just rounded really early if you're even like a couple off. I'm going to error on that side. And then I look at your work too, right? I look at your work and I make sure you didn't just make stuff up and happen to get close to my answer. Yeah, but you're fine. It happens. It happens more than you think. Happened in my geometry class earlier this year. I almost gave someone full points and then I realized they didn't do anything right. They just happened to get close to the right answer. Okay, since there was no questions, I do want to look at a problem like 21, because this is something I could put on a test. All right, this is something I could put on a test because it's not, oh, yeah. 15, yeah, hold on to that. So I'm going to do 19. So 19, we have A, B, and we have angle C. So if I draw that out, if I just draw some stereotypical triangle, and I call this guy A, B, C, we know length A is 12.9, we know length B is 6.4, and we know C, that's not B, side B is going to be 6.4, and we know that angle C is 13.7 degrees. Well, this is a side angle side, but all I'm looking for is half the base times the height. All right? So your base can be whenever you choose. You just have to choose your height correctly. So I'm going to choose that as my height, because that tells me I have an angle across, I have a right triangle, and I have a hypotenuse. So I can now solve for h. And that would make my base 6.4. All right? So whatever you find for h, your area is going to equal half of that base, which is 6.4, times whatever you get from that h. And to find that h, you're just going to do sine of 13.7 degrees. That's going to equal opposite, which is h, all over hypotenuse, which is 12.9. And you use that to get h. And you just plug that in, and then you have your value of your area. That is something that could show up on a test. There are times where you don't know all the information that you might actually have to solve something else along the way too. Okay? If that happened, I'd probably say solve the triangle and then find its area. Okay? And then 15. Did you have a specific question about 15? Because that's a very, very long problem.
Yeah, I got a little tripped up trying to find C at the end. Like, I couldn't get there.
Oh, you couldn't get to C. Did you... let's look at the, I think I have the answer key somewhere on here. I think it was this guy. These are some of the information that they had. Okay, so you did realize it was two triangles, right?
Yeah.
Did you find both of your alphas? So you should have found 45.1 degrees.
Yeah, I got 45.
Okay. Yeah, whatever. That's same. So this one should have been 45.1 degrees. And then how do I find the other one? Do you remember?
Wasn't it just 180 minus that?
Yeah, it actually is. Yep, it's 180 minus that, and we drew our units there. But yeah, it's 180 minus that. And what did you come up with for that one?
134. What was that? 45.24. So
Yeah.
134.7.
Okay. So they had 134.9. I think they had it right there. So it really doesn't matter. We'll just put 134.9. Okay, if you did it 100% correct. Okay, now to find angle C, we just do 180 minus that, right? And that will give you my angle C.
I didn't think about that.
And then we're just trying to find, oh, you struggled, okay. Is that enough, maybe?
Yeah.
Yep, because you just use 180 minus that, that gets you the angle. And then we're just going to use the law of sines that basically says this over sine of that equals this over sine of that. Good job getting all the way there, though. That'd have been, maybe I would have given you 4 points. Maybe I'd feel generous and I'd be like, okay. Actually, it'd be 3.5. But it's 3.5 out of 4. I mean, that's good on a problem like this length. Okay? Are we good on those ish? You're just going to ask yourself, we'll see. Ask yourself, can I, given the information in all three of those and the bell work, come up with how many triangles there are? If you can't, revisit it and practice that. Okay? And then you may want to quickly look at the ones that just say, come up with area, because this one isn't a super hard problem, but you had to understand what to do on it. Okay? That being said, let's go ahead and get into today's lesson. Today's lesson is actually nothing new. It's just applying what we know. Now these are going to be word problems. So gentlemen, if you get stuck on word problems, there is no shame in looking at the answer key to see what kind of shape or whatever they're drawing. Because there's nothing worse than drawing a picture, spending 20 minutes solving it, and finding out your picture was wrong. Because that isn't what math is about. Not understanding the question is not what math is about. It's can you solve a problem. So if you don't understand what they're asking you, look to the answer guide, see what kind of pictures they might have for it, and see if you're on the right path. We're going to start off with bearings. Bearings, you might hear that and tell like I'm going bearing due north or something like that. With bearings, they use numbers. They use numbers, that way they're not over the radio saying I'm going northeast at some number or something. They can just give a number, and control knows exactly which direction they're flying. So how bearings work? They go from 0 to 360 degrees, because a plane can go 0 to 360 degrees, I'm pretty sure. And so what they do is they take your compass that you'd see on any map or anything. So if we have north, we have south, we have east, we have west. North is going to be 0 degrees. And then you're going to go around clockwise. So let's say I'm at 30 degrees. My bearing is 30 degrees. That would be the direction I am going. Alright, so we go around clockwise, and I am now going a bearing of 30 degrees. Alright, we can go all the way around. I can do a bearing of 359 degrees, which means I'm almost going north. Right, 359 degrees would be almost north. I don't think anyone says 360, that's why we put a parenthesis here, because you would just say I'm going north or 0 degrees. So that's why we have these. So a bearing of 60 degrees is considered 60 degrees east of north and is written as north 60 degrees east. So basically you're going northeast. So if I was going 90 degrees, which direction would I be going? What would be an easier way to say 90 degrees? I would just be going due east. And a lot of times if you get to those, if you say 90 degrees, usually you just say I'm going east. Okay, so let's use that information. So we have a plane left Ada and flew 100 miles towards Bern on a course with a bearing of 18 degrees. So we have Ada. So this is how I'm going to do this. I'm going to make a point. And I don't feel like writing Ada, so I'm going to write A. Alright, due north would be this direction on our map that we're drawing right now. That would be due north. He didn't fly due north. Instead, he flew 18 degrees, a bearing of 18 degrees. So rather than going north, he went this way a little bit, 18 degrees. And so he traveled 18 degrees up here. He went 100 miles. And then he reached Bern. Well, let's just call it B. Alright, so we went 100 miles, 18 degrees, we reached Bern. The pilot then flew due east, which I said was a bearing of 90 degrees. 90 degrees means he went due east. It's just going to be a flat line. And he went all the way to Cairo. I'm going to call that C. Then we have triangle ABC. Weird how that works out. Then he went ahead and returned to Ada. And he went on a bearing of 225. A bearing of 225. Anytime we have a bearing, you have to think about where due north is. North would be that direction. So 225 would be me going all the way around and going to 225 degrees. Then it says, find the maximum distance the plane was from Ada. Which point would be the furthest away from Ada? A or B or C? C. Wouldn't be A, definitely. I don't know why I said that. we have nothing marked on this triangle. The only thing we have marked on here is 100 miles. In order to use our law of sines, I need two angles. Can anyone think of at least one angle I can get? John?
C.
We could get angle C. How would I do that?
Well, so usually a circle is 300 and like 60 degrees.
In fact, a circle is always 300.
Yeah. But since like that's due east, so that's 90. So you can subtract 90 from that angle of the circle. So that 225 is out of the 270 degrees in that like used like section. That
Mhm.
So to get just that angle like to itself, you would subtract 225 from 270. And that's the angle.
And that's the angle. What did we come up with? 45.
45.
I didn't mean, I asked the group because I always hate when I get put on the spot. I'm like, I didn't figure that out. Yep, so that one is 45 degrees. I need one more. What do you got?
Angle A.
Angle A. We actually can't find out angle A unless you can think of something I can't because we don't know. Because that would be our 90 degrees, right?
Yeah.
I don't know what chunk that is.
You can just subtract 18 from 90.
But we don't know, this whole thing isn't 90 degrees. This thing isn't 90 degrees. Let me do a drawing really quick. I guess we could find A, but it's going to take a little bit more work. That would be 90 degrees.
Yeah. You can't do that?
Sure, well I can do 90 degrees and we take away 18. So that means this much
Oh, I see. Okay.
is going to be 72, but that doesn't really get me there yet. We could do something on that one. B is a little easier. What do you think we could do with...
Oh, B.
Oh, yeah.
We just make a second right triangle where 18 is.
Is it where the north is?
Yeah.
Oh, yeah.
And then we take 18 away from 90 to get the angle right next to B, which is 72 degrees. Then we take 72 out of 180, which should give us B.
Mm-hmm. So, in short, we're going to extend this and make a right triangle. We know this is 90 degrees. We know this is 18 degrees, right? And we know a triangle is 180 degrees. So we do 180 minus 90 gives me 90. Minus 18 gives me 72. So this guy right here is 72 degrees. Which means this guy right here has to be 108 degrees. All right, now I'm just going to ask myself, well, I have two angles. I'm looking for B. Do I know the degree measure of the one across from B? Yeah, I know 108. Do I also know a side that matches with an angle that we know the value of? Yep, we have 145. That's all I need to use the law of sines. Now we're going to use the law of sines to find a side, so that means I'm going to put the sides on top. I'm looking for B. Well, B relates to the sine of 108 degrees. The same way side 100, the 100 miles, would relate to sine of 45 degrees because they're right across from each other, right? And now we just got to solve for B. We just multiply both sides by sine of 108. So we have B equals sine of 108 times 100 over the sine of 45 degrees. Did anyone solve for B yet? What did you get? 134.5. That is exactly what I got. 134.5 miles. 134.5 miles. Done. Hard part about this problem is really just setting it up, understanding what they mean by their bearings. So that's what I mean by, if you're not sure what they're asking, maybe just double check the answer guide, whether it has pictures or not. At least it can give you numbers and be like, I don't have anywhere near those numbers. Maybe I did something wrong. Okay? All right, we just have one more to do. And this one was a problem The very first time we saw this problem, it took an entire page to solve. And once I draw the picture, you might remember it. All right, we have a tower. It doesn't take a whole page this time. It's actually just two little equations. Okay? And one of them we get to use just SOHCAHTOA. So, let's not panic yet. Okay, so we have the angle of elevation to the top of a tower from point A is 19.9 degrees. What time is this class up? Oh, we got plenty of time. We're good. All right, the angle of elevation to the top of a tower from point A on the ground is 19.9 degrees. So that means I need a tower. I'm just going to draw a straight line for my tower. But we know it's a tower because I'm going to label it as T for tower. Nailed it. All right, now we have point A somewhere out here. Well, point A, if I look straight up at the tower, let's label that A. If I look straight up at the tower, is going to be 19.9 degrees. Well, I can't solve anything from that yet. So we're going to continue on. It says from point B, which is 50 feet closer to the tower, the angle of elevation is 21.8. So that means B is closer to the tower, so we'll put it here. And it's 50 feet closer. So the distance between A and B is 50 feet. And we're looking up at the tower, and that's going to be 21.8 degrees. Do you remember seeing this problem? With the tangents, and we had to... When you do it this way, it's a lot easier. Okay, so here is our ultimate goal. My ultimate goal is to get to T, which means I want to get to this right triangle, because right triangles are easy to solve. I want to get to this right triangle. Well, in order to do that, I just need to find this hypotenuse. Because once I know this hypotenuse, I know the sine of this is going to equal T over my hypotenuse. So I just need to find this hypotenuse here. So that is my goal, to find A. In order to find A, I'm going to use this triangle here. Well, we can almost use this triangle because I have an angle and a side. How can I get another angle in that little sliver? Think about it. There should be more than two hands up. JP, what could I do?
Do 90 plus 19.9, and then subtract that from 180 to get 70.1, and then you know 70.1 plus 21.8 plus 90 equals 180 for the triangle on the right, so then you subtract whatever value from the 70.1 to get the angle on the top right.
Wow, that would absolutely work. What's an easier way, though? Peyton.
Take 180 minus 21.8 and get that angle.
Find this angle.
I like my way.
Your way absolutely would work, right? Absolutely. We're just going to use Peyton's because we have time constraints. So we're just going to do 180. Great creative thinking, though. You really worked your way around it. It took me a while to make sure you're on the right path, but you got there. So it's 180 minus 21.8 degrees. So what is that, my angle? What's my angle? Anyone? I'm almost there. 8.2. 158.2. Okay. And that will get us to that top angle. We're just going to do 180 minus, same thing. What'd you get for that angle?
1.9.
And that is the correct angle, 1.9 degrees. So however you get there, you get there. You want to get to that 1.9 because I want that angle across from 50 feet because that's what I'm going to use my law of sines with. All right, I always want to have one where I know the angle and the side across. So now I'm going to use this angle and this side across to solve for A. So we're going to say A relates to the sine of 19.9 degrees, the same way that that 50 feet is going to relate to sine of 1.9 degrees, which means A is just going to equal something I can plug in my calculator, which is the sine of 19.9 degrees times 50 over sine of 1.9 degrees. And did anyone get that measure yet? Callie? 513.3. That's exactly what I got. 513.3 feet. That's just A though, that's not the height. My height is still T, so we're almost there. We got our A. What I'm going to do, and you don't have to do this, I'm just going to redraw that triangle that I'm going to use next. So I'm going to say, hey, I used that little section to get that. Now I'm just going to redraw this so I don't have too much stuff in my way. So this is just that smaller triangle where this is B. This is 21.8 degrees. Our A is now 513.3. This is still 90 degrees. This is still my T. And that is all the information I need because that is a right triangle. Which one of my trig functions deals with opposite and hypotenuse? Opposite and hypotenuse. Opposite and hypotenuse. Jake? Not tangent. Think about SOHCAHTOA, because tangent would be opposite over adjacent. I'm looking for opposite over hypotenuse. You got there. You just had to run through the other two. Remember, SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we're going to use sine of 21.8 degrees is going to equal opposite. That's a 6. Opposite is T over my hypotenuse, which is 513.3. Multiply both sides by 513.3, and you should come up with T equals 513.3 times sine of 21.8 degrees. And can someone give me that value? Not Callie, because she got me my last one. Charlie?
190.6.
190.6 feet. I believe I rounded it to 191, but I like 190.6 feet. Did it take an entire page? No. In fact, I could have done this in a much smaller area, right? I wrote pretty big so you guys could see everything. Yeah?
Why don't we do just the sine of the entire triangle?
The sine of the entire triangle?
Yeah, like, so why don't we just give the initial, like, the total hypotenuse?
Oh, you could. That's another way to do it. So you could get this hypotenuse by using this. Yep, you could absolutely do that. Yep. Definitely a valid way to do that. So you could have used that 158.2 degrees to get this length, which would have gotten you there. Same exact, we did the exact same. I mean, I just found a different hypotenuse than you. Same number of steps though, right? Because I didn't have to redraw this. We just had to find this one or that one. Same. Same. Is that what you did? Came with the same answer, right? Yep, about the same number of steps. Yeah. Okay, that was a good question though. So absolutely you could have found this hypotenuse instead and used it the same way. All right, any questions? Okay, so